Hello everyone, welcome to Scanfil's and Etteplan's joint webinar about cost reduction and life cycle services. It's a privilege to have you today here online with us, and I hope you will enjoy the next 30 minutes. Today we will have on the agenda strategies for cost optimization, how to identify non-value adding product features and the process of cost optimization. And we will wrap up the webinar with a questions and answers session. So if you have any questions, please feel free to write them in the webinar tool. My name is Antti Tolvanen. I will be facilitating this webinar, and the speakers for today's session are Reijo Kalenius from Scanfield and Jonne Eilemo from Etteplan. I will start by giving an overview of Scanfield and Etteplan. So Scanfield is a contract manufacturer with a great global footprint, well-established company with revenues of €500 million and around 3,500 persons, with some 10 factories in Europe and Americas and Asia. Scanfield has a quite broad portfolio of different customers in different industries, and I would say Scanfield's competitive advantages include high levels of fulfillment, cost efficiency, and quality. And together with Etteplan, we have ongoing several nice projects where Etteplan is acting as the contract developer and Scanfield is acting as the contract manufacturer. I will then present also a bit about Etteplan, what we're doing, and which also illustrates the scope of projects where we also do cooperation. So Etteplan is a contract design company, and we have three main businesses. We have engineering business that focuses in on making the bigger products where the products are based on maybe third party or commercial control systems, like different control systems from different automation technology providers. So here the core competence in our engineering division are mechanical engineering, automation, and electrical design, and we're investing quite a lot right now and leading competent capabilities globally related to designing metal parts for additive manufacturing. In addition, we also design manufacturing lines for products. So with Scanfield, we do cooperation related to how to say bigger products with commercial control systems, and also we have projects where embedded device creation is involved, where our joint customers are developing customized control systems. And in this area, Etteplan's core competences include power electronic products with high voltages, and then all kinds of low power radio devices that are perhaps used all over the world, and which understanding these compliance requirements brings in other challenges. Then we're working a lot on 5G ready private networks. We're supplying to factories and our customers private LTE networks, and we have very good capabilities in quality assurance, including software test automation, testing team. We're one of the biggest suppliers in Finland related to production testers. We have also in Sweden, Germany, and the Netherlands good capabilities for manufacturing line development. And we're specialized both in functional safety and cybersecurity of products. And part of our portfolio also consists of medical and in vitro diagnostic products that we're developing and maintaining. In addition, Etteplan can support with technical documentation, the use instructions manuals, and also build different kind of applications and background systems that are needed, for example, for running IoT-based business models. So here's a quick introduction to Scanfield and Etteplan. And now I would like to give the word over to Mr. Reijo Kalenius from Scanfield.
Thank you, Antti. So let's dive into this area of cost optimization, and I will start with explaining some strategies and why we think design services are important when it comes to cost optimization. This is a slide that we have used for long time, but it's still very much valid. So if you think about the cost structure of a typical product and how to reduce the cost, normally you start looking at the bill of material. You think this is the biggest cost element. How can we decrease the BOM value, and then you start splitting the bill of material into the highest cost items and take maybe 20% or even 10% and look at the cost of those and how can we reduce it. And of course also you think about the operational savings, although that is normally not such a big and important factor. But if you think about the elements that have the biggest influence in the total cost of the product, studies show that by far most of the product value is or product cost is defined already at the design department, at the engineers tables, and we say 70%, but anyway it's a substantial figure, and I will show you that the biggest impact that you can have on the product cost comes through impacting the design. Now if we jump to the product lifecycle, and Scanfil as a company is mostly working in business to business, and the life cycle of a product can be 10 years, 15 years, even up to 20 is it's sometimes seen. Antti, can you jump to the next slide? Yeah, so in the beginning, when you are designing the product and introducing it to production, of course the focus areas are innovation. You want to have the latest technology. You think of features that add value to the customers and end users. You think of future proofing. How can we make sure that there's no surprises down the road with components disappearing from the market? And of course, especially with IoT nowadays, time to market is increasingly important, because there are businesses where it's the first company who takes over all the market basically. And DFX is of course something that we like to talk about because we are a manufacturing company. But as the product matures, the innovation fades away, and you lose the technological advantage. Your competitors come up with similar products that have normally similar features. So then in the mature phase, you come to a point where you need to decide if you want to somehow increase or extend the life cycle, or start ramping down the production and preparing for that. And then the important topics are obviously still new ideas, technologies. Maybe the volumes of the product are not what you thought they would be in the beginning. Perhaps there are new manufacturing technologies. If you think 10 years, what was available 10 years ago, it's a very different situation than what we have today. And then optimized customer value. You have learned what are the features that the end users really value, and is there something that is not absolutely necessary for them. If you take out those kind of features, of course, you can optimize the cost of the product significantly. And life cycle assessment, of course, and extending the life cycle should always be done in that phase in connection to any other remedies that you may have, because of course you need a couple of years more to reap the benefits of the design changes. And of course, why we are partnering with Etteplan, for example, on cost reductions is exactly this area that we see that bringing in a design team and looking at the product and together with our manufacturing engineers really brainstorming and making a cross-functional team to look at the product adds very much value, and we can come up with very good results that way. Then let's jump to some examples. Maybe those better explain what I was trying to say. So new ideas, technologies. There's a device that was made for some kind of liquid handling application, and this was a kind of a waste tube that takes the liquid from one place to a trash can that you can throw away. Previously, it was made by machining a couple of parts and then welding those together. But of course, everybody who's done something with mechanical engineering knows that machining and welding are nowadays more or less curse words and bring up unnecessary cost. Whereas sheet metal fabrication has developed significantly in the last years, and in this case, that was exactly what we did. We took away the machining and welding and made the whole assembly from a single bended sheet metal part, and this one part reduced the cost of the product by tens of euros. Optimized customer value. Sometimes, like in this case, the expectation of the volumes for the product wasn't that big, but then surprise, it was very well received in the market, and the manufacturing volumes were a lot higher. So then you have some possibilities, like here you can invest into plastics tooling and make it much better looking. So here we did basically a complete redesign of the product. We did some cost reduction elements. There was some commercial controllers, for example, that we took away and designed ourselves. So the embedded electronics is now running on a custom PCBA. And then, of course, the aesthetics of the product, it's what the customers see, and that you can see has changed dramatically. And at the same time, we were able to take away 30 to 40% of the product cost, depending a bit on the variant and what is included, because there are 4 variants of this product. Optimized design solutions. Here's a very nice example of what this future proofing that I mentioned can lead to. So the original design team had put in a possibility for Ethernet connectivity, and all the hardware was there, but it was never implemented in the software. So this port that you see, and there was actually a separate IC chip controlling the Ethernet connection, was totally unused. So that is a no-brainer, obviously, that you take that away, and it's no impact to the end users, but the manufacturing cost goes down significantly. And extending the life cycle, here's a simple PCBA that was made with manually mounted components, and one of those was going obsolete. So we not only changed the obsolete component, but updated the design to machine mounting, and of course it extended the life cycle, but also reduced the cost. Yeah, and then a bit more on the types of non-value adding features that we typically see, and this is what you can impact on the design. Reservation made for future proofing. I already mentioned the Ethernet port, so that is very easy, but sometimes still difficult to decide that do we take that away or will it be implemented later. But of course, the sooner you make that decision, the more savings you reap during the remaining life cycle of the product. And then there's some nice to have features that are not critical or crucial to the end user. They are not the primary function of the device. I don't have a picture of this example, but we had on an industrial analyzer some time ago a kind of pen holder where the end user could place his pen or pencil, but even the product manager at our customer did not know that there was such a feature, and it was adding cost to the product, and it was very tricky to manufacture and caused a bad yield at the supplier of one of the parts going into the product. So of course, then you can think that how much value are the users placing to this feature, and how much would they pay for it? And that's a very good way to take away cost from the product. And another type of feature is something that is targeted at a specific user group that is in the minority when you think of different users. On the same product that had the Ethernet port, it also had this option of becoming a mobile unit. So normally you run it with external power supply on a table, but it also had this option that you can run it on batteries and take it with you. But the battery users were very much in the minority, maybe 1 or 2%. So of course, then the question is how much do the batteries cost, and would it add sales if you take away the batteries and maybe design an external module to provide that functionality and sell that to the 1% instead of 100% of the users paying for the feature? Yeah, that is what we have seen, the types of features that don't add value to the product or to its users. There are some formal tools. There's one graph here. I won't go into that in more detail and try to explain it to you. There are formal tools designed for analyzing and breaking down the functions of the product, and then deciding which ones to keep and which ones to take away. But what we have seen is that normally it's faster and efficient enough to just gather a multifunctional team, bringing in the engineers, production, product managers, maybe even some end customers if possible, and brainstorm around the product and talk about the issues that you have seen over the product's life cycle. And then of course, normally as a result of this analysis, you list the things that could be done, and then think of the benefit that you would achieve with the change versus the cost of implementing a change, and typically calculate the payback time, the bang for bucks related to the change. And when you're at the end of the life cycle, I would say typical specification for the payback time is around a year. So if it's more than 12 months, you do not start such an activity. But if it's less, that's a very easy decision. That was my part. Thank you very much. I hand over to Jonne.
Thank you very much, Reijo, and pleasure meeting you all this afternoon or day. So my name is Jonne Eilimä. I work as a sales manager at Etteplan, and I'm based in Espoo, Finland. I'll walk you through the cost reduction process itself. The first step would usually, or often in cases like this, is to actually set a target for the project so that you actually know or have something that you want to reach. So what is it? What is the desired outcome of this project that we're now starting? The second step would be to collect all the basic data that's currently available of the product that you have in manufacturing, be it then let's say bill of materials, any source files, any drawings, or any documentation that's sort of available, or what you could have at hand at the moment, and deliver those to us. And one aspect also, of course, is the annual volumes that you need to know. How much would you like, or how much do you see yourself manufacturing this in the near future? Thirdly, we'll set up a cross-functional team with experts, obviously, both from us, Etteplan and Scanfil, as well as you as a customer. If you want to be present in this planning phase, then please do so. And by this, we'll ensure that we have the correct expertise at sort of present in the planning phase. Then we'll move on into kickoffs and start the cost reduction process by doing workshops. We'll interview any operators, any stakeholders that you possibly have. So to say, your customers. Are there someone who knows more about your products than you, or someone who has specific needs for them? Then we'll also, of course, identify any key product features that need to be present in the new design as well. We'll do brainstorming. This is always a good thing. We'll bring also some here, let's say some from the accounting department could be present here as well. I mean, someone who is not necessarily in the product business daily, they can be in these sessions as well, so that we get out of the box ideas into this planning phase. And we'll do a functional analysis. This is what Reijo mentioned or said about, for instance, the Ethernet port that was present in one of the designs but was never used. So we'll do a functional analysis so that we can see and document how the device is currently working and what are the features that need to be working in the future. And then we'll review all the features that are currently present there, and again do a cost versus value comparison to know is it a lower price or is it more functionality that we need in the new upcoming design. Then some time most probably has passed before we move forward. I mean, there has been some engineering and planning work in the background, and then we'll go and move on into the results presentation and make a change proposal for this new device. And actually we'll present you 3 different levels. This will be on the next slide on the next slide, but we'll give you 3 different levels of changes to know that is this, or sort of what is the desired outcome now when we have all the background data. The savings potential will be calculated per change level. Obviously also the development time, how long does it take, and how much will the non-recurring engineering cost be with these changes that we plan to do. And based on these, we can of course calculate the payback time and do a risk assessment of the features. They could be on a component level or feature level as to sort of what are the risks with this product or this selection of components in the future. Will it be manufacturable for 10 years, or are there any risks in any of the components? And then if there are any new features that will be brought onto this redesigned device, it could be, let's say, if we change one module from the existing design, the new module could have some functionalities that were not present in the previous design. It could be new, let's say, connectivity options or very sort of random stuff that we've not thought about before, and see if that's something that could bring value to your customers. Is it good to pay the extra price for the component to bring these features to your customers? Then we'll review. The next step would be obviously to review and make a decision based on these different levels of optimizations that we can do, and then do the implementation itself. Move on to the implementation project. Will it be a completely new development project, or will we make a plan that will make smaller iterations throughout the process and change the product over its life cycle? And to give you a better idea, or to open up a bit as to how big these changes can be, we've sort of done this in 3 different levels. The first level, or level 1, is just, let's say, 1 or 2 component optimizations. This means that we can change maybe one EOL end-of-life component or an obsolete component, and this will not necessarily have to be made in a way that we need to touch the design of the device. And it's pretty straightforward. We change the components and that's it. Usually speaking, the cost saving in the level 1 projects could be a couple of %. But then if we move on into a minor hardware change, a bit larger, let's make some minor adjustments to the hardware itself, and then we go on into level 2. And here we usually have to touch the layout, for instance, itself. And this then again brings with it that we need to retest the device, ensure that it's working as designed before. The cost saving, or the development time, is a bit longer in level 2, but then again the cost saving could be up to 10%. And then the third one, level 3, is a complete redesign of the device. We bring all the existing functionalities and possible new functionalities that we want to do into into this new device and make a complete, in a way, a new hardware project. The development time is the longest, but then again, the savings potential could be up to 40% in these cases. So these 3 sort of levels are what you could be striving for with your products, and the expected, or depending on the life cycle, as to how long do you want to manufacture it, or how long do you see yourself selling these devices in the future.
Okay, thank you so much, Jonne. Now, in case you have any questions, please write them in the questions bar or a chat. And meanwhile, while you think about questions, I would like to promote to you the next Etteplan webinar that we're going to have on Tuesday, December 1st. So there's actually EU is planning to regulate the cybersecurity of radio devices, and then also EU is planning to regulate operational technology, IT, cloud services, cybersecurity via so-called cybersecurity certification schemes, and in US, there's coming a legislation for the regulation of devices that the federal government is purchasing. So we're going to be talking about this next Tuesday about how to develop secure embedded products. You can see here down in the screen the link to the page where you can enroll, where you can find the enrollment for our next webinar next Tuesday. And I hope that to see you on, or how to have you in the audience also next week. Okay, any questions? Let's see, we have one question here. Your recommendations for ensuring proper balance between cost and availability in the supply chain. So how to approach cost and availability? Reijo, would you have comments on that?
Yes, that is a very tricky question, and I would say, well, depends a bit maybe on the component that we are talking about, but of course we aim to work with reputable manufacturers. We have tools for looking at the component life cycles and tools that forecast the remaining life cycle, and of course you can look at the consumption of the components on the market, etc., and that way find good solution. But it is always tricky, and especially now the times being what they are, there can be surprises, but so far at least we have I think survived quite well and not seen any issues. But yeah, being proactive is the key, and that's why we have component engineering services available to look at the component life cycles and work proactively on them.
Very good. We have the next question. Products have different standards. How do you make sure that you fulfill the product standard? Normally it can take years before you actually understand the product standard. So I could answer actually this. We, in a redesign project or a completely new design project, part of our pre-studies on planning phase is to identify all the applicable standards that are relevant for this product and in the market. One good example is medical devices and radio devices and devices that have functional security requirements. And here we either use in-house specialists for confirming that these requirements are the right ones. From design perspective, radio device regulations is one thing also. And in case there are some standards that we are not familiar with, we then bring in specialists from our partner companies into it. And often also our customers that market the devices themselves have a pretty good hunch on the applicable standards that are affecting their products also. So it varies. Do you, Reijo or Jon, have something to fill in here? Not okay.
Not really, no.
Yeah. Okay, then we have the next question. Then what is the relationship between quality and cost?
Maybe if I take that, I guess there is a relationship, but we don't really see those two being put against each other. So within our customer base, I think quality, the quality expectation and the quality level is always set, and that's a given fact. And then we have to find ways to reach that level in a cost competitive way. But normally our customers do not jeopardize quality to get to a cheaper cost.
Thank you. Then there's a question, can we receive the presentation as a PDF? So I would encourage you to reach out to Reijo and Jon for a presentation handout, and this webinar will be also published in YouTube later on. So please, you can then get the link from Jon or Reijo. Then we have a next question here. Just a second. The next question is, okay, now I see in your presentation that accredited testing is only for CE, but that means you can design and test according to low voltage directive. Yes, many of our products that we design and developed are kind of under the low voltage directive also.
And actually, in addition, the presentation itself had accredited testing and CE as an example. But I mean, as Antti mentioned before, during the design or planning phase, our compliance and market access team ensures sort of the right testing to be done for this device. And then we conduct those tests that need to be done.
Good, thank you, Jonne. Then the next question, how are the costs handled normally for the project as such, and the profit from the project and the product? So I suppose this question is related to the commercial model.
Yes, well, I think we are open to discuss. Normally, of course, our way of working as an EMS, and I think Etteplan has the same way, is that the customer pays the cost and then gets all the benefit also. But we can talk about the way of financing it and sharing the cost.
Okay, thank you, Reijo. I think that concludes the questions. If you don't have any other questions, I would like to thank the audience for the participation, active participation, and I wish you a very good day.